Hello and welcome back to April May Codes. Today I'm going to go over briefly how I created my map in Tiled, and then I'm going to get started on putting my map into the game. So I have Tiled open. If you're not familiar with Tiled, I believe it's mapeditor.org. You can download it from there. It's on itch.io. Um, so what I have here is my map. It's open, but I have all of the layers set to invisible. So I'm just going to go over layer by layer what I did. Let me make this a little smaller and zoom out a little bit. All right, so for my ground layer, I put these cliffs in on the left side and on the top because I didn't want you to be able to go off the map in those directions. And then I've just got my ground. It's got some grassy tiles. Some of them are a little bit different than others. And then for my water, there's a little pond right outside the house. So I put the water in its own layer. Next is the house base. So that's just the bottom part of the house. It's in a separate layer from the top because when we put those on the screen, they're going to be in separate layers. So when the player walks behind the house shows up in front of the player. Next, I've got my hills, which are here. So that's just a little area the player can't walk through, but if they come up through this little entryway, then they'll be able to get into this little hill area. Then I put my paths in. So I've got paths from the house to the hill area, paths going down to the animal area. This is where you can build your barn and your coop for your animals. And then paths going to the right and to the bottom of the map to zone to different areas. After paths, I did my farmable area, which is this whole area in here, with the exception of the very bottom and very right squares because those are fences. The reason I did this is so that when the map is created, we can create specific farmable tiles so the game knows which tiles are able to be farmed, basically. So that one is going to stay invisible. That's not going to show up on our map. We're going to create the tiles, but we're not going to see them. Then I did my player, which just is a few things here. Let me zoom in a bit. There's the marker here, which is the player start. So when we start our game, this is where they'll show up on the map. There's this rectangle here, which is what did I call it? Let's go to view. Highlight current layer is selected. Because I'm not on player. There we go. All right, so I called that enter farmhouse. So when the player is in this area here, let's make it a little bit smaller actually, and they hit enter, they will enter into the farmhouse. That should be good. Then there's the player start icon. This is exit the farm south, and over here we have exit the farm to the east. So that's what's in the player layer. Then we have our fence, which is right here. Oh, I didn't make it visible. Okay. Our fence outlines the map basically, and we have it going around the animal containment area as well. Next, I put a house top, so there's the top of the house. And then I've got collisions. This is another invisible layer. I just put these so that the player can't walk past these squares. So we've got collisions around the hills, we've got collisions at the cliffs. The fence is created as a collision object, so I didn't need to put collisions there. And then at the top here. Oh, I did put collisions around the fence. Okay. And then the water as well. We can't walk into the house or the water, or the fence or the cliffs. All right, so collision stays invisible. And the last two we've got are the decorations. I added this fountain and these two little statues. And then I also added a bin. That'll be the shipping bin and a mailbox. And then the trees, which we'll make visible. And here we have our stumps down here. These are going to go away permanently once they're chopped down. The trees are going to just show a stump once it's chopped down. And then after a few days, it will regrow. I have to figure out how to implement that. But that's the difference between the stumps and the trees. And you'll need an upgraded axe to chop down the stumps. So that's how I created my map in Tiled. You just import the sprite sheets that you need and take the squares and put them where they need to go. And for the objects, they need to be imported as that's separate as object items so you can place them on the map and scale them up as you need to. So that's how I created my map in Tiled. Now I'll go ahead and open up PyCharm and we'll get to work on putting the map into the game. So I've got PyCharm open, and this is going to be a little bit different than my last videos because instead of planning it all out ahead and writing a script, I'm just going to be kind of coding as I go. So bear with me. I'm going to start by going to my config file and adding in my layers. And there's going to be different layers for the different zones, I think. So we're going to call this farm layers. It's going to be a dictionary. We'll start with the ground is 0. Then I did my paths, hills, and fences is 1. Soil is 2. Soil water is 3. A lot of these we won't be using just yet. Rain floor is 4. Plants and rocks is 5. Buildings is 6. Ground plant is 7. Main is 8. House top is 9 because we want that to be above main, so when our character walks behind the house top shows up on top of them. And raindrops is 10. All right, we've got that in there. Now we need to create some sprites. Most of this came from Clear Code Stardew Valley inspired game tutorial. So in sprites, we're going to create a new file, sprites.py. And the first one we're going to do is just going to be called generic. So we'll import pygame. We're going to need to import config. And that should be all we need for now. So we'll create a class generic, which inherits from pygame.sprite.sprite. Init will take self, a pause, a surf, groups, and a z, which we're going to set equal to config.farmlayers main. So by default, everything will be on the main layer unless we specify a z. And we'll do super.init, which will take groups. Self.image is equal to surf. Self.rect is equal to self.image. dot get rect, and the top left is going to be equal to the pause. Self.z is equal to z. And we'll go ahead and give it a hitbox now as well. So self.hitbox is equal to self.rect.copy.inflate. And then we're going to do negative self.rect.width times 0.6. And then negative self.rect.height times 0.75. All right, that is it for the generic class. I'll create a class water, which inherits from generic. That's going to take self, pause, frames, and groups. Self.frames is equal to frames. Self.frame index is equal to 0. And then we'll do super.init. And that's going to take pause, self.frames, self.frame index as the surf groups. And the layers is going to be config.farm layers water. And then this needs an animate function. We'll take self and delta time. Self.frame index plus equals 5 times delta time. If self.frame index is greater than or equal to the length of self.frames, got a colon there, self.frame index is equal to 0. And then self.image is equal to self.frames, self.frame index. And then it needs an update function, which takes self and delta time. And we'll do self.animate and pass in delta time. All right, now we'll create our tree class. Let's put an extra line here and an extra line here. Get rid of those squiggly lines. The class tree inherits from generic. Init is going to take self, a pause, a surf, groups, a name, and that's it for now. Then we'll do super dot init is going to take pause, surf, groups, and z is equal to config dot farm layers, and we'll put the trees in house top because we want the player to be behind them as well. Self.name is equal to name. And let's see, the rest of this we don't need to add just yet. So now we will create our class interaction, which inherits from generic. That takes self, pause, size, groups, and name. Surf is equal to pygame dot surface, and then the size, self dot surface rect is equal to surf dot get rect, and the center is equal to pause. We'll do super dot init, and that takes pause, surf, and groups. Self dot pause is equal to pause, and self dot name is equal to name. All right, and we have one more class to create here, and that is going to be the farmable class. If you watched ClearCode's Stardew Valley tutorial, you'll see that he creates the farmable layer in a much different way than I do. I made my own map when I was following his tutorial, and I couldn't figure out the numbers basically to get my map to work properly with the way that he creates the farmable sprites. So I did it this way instead. I created a new class called farmable, which inherits from generic. So we'll do def init, which will take self, pause, surf, and groups. Super.init takes pause, surf, and groups. Self.image is equal to surf. Self.rect is equal to self.image.getRect. And the top left is equal to pause. Self.z is equal to -1 because we don't want this to show up on the map. I probably didn't need to do -1 because the farmable layer is set to invisible anyway, but it works like this, so I'm gonna leave it like this. Then we need 3 attributes, a self.tilde equal to false, self.watered equal to false, and self.plant is equal to false. So these check if the soil is tilled, if the tilled soil has been watered, and if the tilled soil has a plant in it. So we'll use those later on. All right, we're done creating classes, so on to the fun stuff. We're going to go into farm.py, and in setup, above where we create the player, we are going to, well, first we'll need to import pygame. It's the library we're going to use to load our farm map, because you'll notice the tiled maps save as .tmx files. So we'll import pygame, and we'll install that. All right, now down in setup, we're going to set our map data equal to pygame dot load pygame, and then the path for our map. So I could not get this to work when I put the map in the actual PyCharm project. I'm not sure why, it just would not load the map properly. So what I did instead was put the absolute path to my map. So let me grab that real quick. Simfarm.tmx. Okay, that's the one we want. All right, and now for x, y, surf in map data dot get layer by name, ground, because we're going to start with the ground layer, dot tiles. And then we're going to scale it up a little bit. So we're going to say the transformed surf is equal to pygame dot transform dot scale. And we'll do the surf. And the x and y will be 48 by 48. Or I think I said x and y, that should be width and height. The height, it's the size, is 48 by 48. And then we're going to create an instance of our generic class for each tile. So we'll do generic, and that's going to take a position. So that's going to be x times 48, y times 48. Then the surface is transformed surf. Groups is self dot all sprites. And the layer for that is going to be config, spelled that wrong, config.farm layers ground. My O key is sticking. There we go. Let's go ahead and import generic. All right. And that creates for every tile in the ground layer, it creates a generic, an instance of the generic class at the x and y coordinates that we specify, the x times 48, y times 48, with the transformed surf being the image scaled up to 48 by 48. I probably could have done this differently by making my map 48 by 48 instead of 16 by 16, but I was learning, and this is how I did it. So this is how I'm setting it up. So then we're going to do the house top. So we'll do for x, y, surf in map data. Oops, I forgot a comma. Dot get layer by name. And this one is called house top dot tiles. We'll do transformed surf again is equal to pygame dot transform dot scale. We'll do the surf, and that's going to be 48 by 48. And then we'll do generic. And then in a tuple, we've got x times 48, y times 48. So I can probably copy this code a few times. We'll put transformed surf, self.allSprites, and the layer is going to be config.farm layers house top. Then let's copy this few lines of codes here. What did I do wrong? Oh, I forgot a comma. Let's copy that with the comma. And then we're going to do the house base, which my layer is just called house base. And then that goes in the farm sim or the farm layers building. Building or buildings? I think it's buildings. All right, and then we're going to do the paths next, and that is also generic. So for xysurf in mapdata.getLayerByName housetop.tiles. The transform surfed is equal to pygame.transform.scale surf, and the size is 48 by 48. And then generic x times 48, y times 48. And the layer for that is going to be paths slash hills slash fence. Paths slash hills slash fence. Probably could have named that better, but oh well. Next is going to be, hope I need to change that layer name. That should be paths. After paths, we'll do hills. And that's going to go in that same one. So this will be paths slash hills slash fence. And then we'll do the fence. And that's going to be the same one as well. So I probably could put those all on the same layer in the map. All right. Now I need to import my water frames, which I'll need to copy over. So give me just a moment to grab those. That is here. Copy. We'll paste that in assets. So now we've got our water tiles. These are just so that the water has some animation, so it's not just a static frame over and over. And this all came from ClearCode's Stardew Valley inspired game tutorial, so I highly recommend you check that out. But before I can do the water tiles, I need to add a file to my support.py file. And this is also from ClearCode, from that Stardew Valley inspired game. So in here we've got our tile sheet, we've got our timer. Now we're going to create a function. We'll just call this import folder, and this will take a path. Surface list is going to be equal to an empty string. And for underscore, comma, image files in walk path, we're going to need to import walk. For image in image files, full path is equal to path plus a slash plus the image. Image surf is equal to pygame.image.load full path dot convert alpha, and we'll do surface list dot append image surf, and then we will return. Whoops, I need to go back one more time. Return surface list. Now let's import walk, and that is from OS, and that should be good. If you're confused about what this code does, it basically takes the path and walks through everything in that folder or any subfolders in it, and returns all of the images. ClearCode explains it really well in his tutorial, so again, I really recommend checking that out if you're confused about what any of this code or any of the code in the setup for farm.py does. So now we'll head back over to farm.py. Let's move this over a bit so we can see what we're doing. And we're going to set our water frames equal to import folder, and the path is going to be assets/water because that's where I put my water tiles, are in there. Let's import the import folder function. Now we have our water frames, so we'll do for x, y, surf in map data dot get layer by name. The name is water dot tiles. We'll do the transformed surf is equal to pygame dot transform dot scale, and that's going to take the surf, and then the size is going to be 48 by 48. And then we're going to make a water tile instead of generic. The position is going to be the same, x times 48, y times 48. Then our water frames, and then self.allSprites for the group. All right, that should do it for our water frames. Let's import the water class. Now we'll do our collisions. So for x, y, surf in map data dot get layer by name. Oh, you know what? I don't think I made, oh no, these are generic, so that's okay. The name is collisions dot tiles. We'll do generic, and that's x times 48, y times 48. Pygame dot surface, and the size is 48 by 48. And that needs to be in a tuple. And then self dot collision sprites, which we haven't made yet. So let's go ahead and make that group now. So we'll scroll back up here under all sprites. We'll do self dot, my O button is sticky, collision sprites is equal to pygame dot sprite dot group. There we go. All right. So we've got our collisions in there. We'll handle collisions in a future video. Now we're going to handle our farmable tiles. So for x, y, my comma's sticky too. In map data dot get layer by name, the name for this is farmable dot tiles. We're going to do farmable, and we've got x times 48, y times 48. we're going to make a pygame.surface that is 48 by 48, and that needs to be a tuple. And then the groups is going to be two. It's going to be in self.allSprites and self.farmablesprites, which we need to create. So let's scroll back up. Self.farmablesprites is equal to pygame.sprite.group. All right. Let's import farmable. Now let's make the trees. So we're going to do this a little bit differently. Instead of doing getLayerByName.tiles, we're going to do for object in map data dot getLayerByName, and this name is trees. And if not object dot name is equal to, I think I called it lowercase xl and then capital STUMP. Let me double check. Give me just a moment. I'm going to pause the video. All right, that is what I called it, was XL stump. So if the name is not XL stump, then we're going to go ahead and create a tree class. That's going to be tree. And let's do this like this. Pause equals object dot x times 3 object dot y times 3. And that's because 16 times 3 is 48. We're scaling everything up by 3. So we're going to scale these up by 3 as well. Is that right? Because I made these 96. That's 6, so that's double. Is 48. So I wonder why I made them 96. It looks right. So I'm going to leave that as it is for now. So we do object.x times 3, object.y times 3. The surf is equal to pygame.transform.scale. And then we'll do object.image. And then the size I made it was 96 by 96. Groups is equal to a list. So you've got self.allSprites, self.collisionSprites, and self.treeSprites, which we need to make. So let's scroll back up. Self.tree, oops. Sprites is equal to pygame.sprite.group. Okay. So there's our groups. And I'm forgetting commas. After our groups, our name is going to be equal to the object name. And then that is all we need for the tree for now. Let's import tree. All right, we've got a few more to do. So we're going to start on the player layer now. So we can actually get rid of this line. And what does the player take? The position, the game, and then self.allSprites. So I'll remember that. Position, game, self.allSprites. So we're going to do for object in map data dot get layer by name. The layer name is player. If object dot name is equal to farmhouse start, then we're going to create our player. So self.player is equal to a player, and that takes a position, which is going to be object.x times 3, object.y times 3, self.gamemanager.game, and self.allSprites. And you know what? In my original code, I actually gave the game a reference to the player here instead of doing it in title. And I think I like that better. I guess there's no difference, but I'm going to do it that way. So we're going to take that line out of title. And we need to take it out here as well. Then we'll go back to farm.py, and right below where we create our player, we'll do self.gamemanager.game.player is equal to self.player. So it's basically doing the same thing, but we're doing it in the setup of the farm instead of in the when we click on the title screen button. All right. Now, if object.name is equal to enter farmhouse, then we'll do an interaction, which takes a pause, which is going to be object.x times 3, object.y times 3, the size, which is object.width, and then object.height, self.interaction sprites, and then a name, which is object.name. And we need to create interaction sprites, I believe. Yep. So self.interaction sprites is equal to pygame.sprite.group. And these are all grouped with a capital G. Let's import interaction. We'll copy this line. And then if object.name is equal to exit farm east, we'll do the same thing. If object.name is equal to exit farm south, that's capital S, we'll do the same thing. And that's it for the player layer. We've got the player starting position, the enter farmhouse, and then the 2 exit locations. Now we need to do our decorations layer, and then we are done. We should be able to see the map on the screen, I believe. So we'll do for object in map data dot get layer by name, and this is called decorations. If object dot name is equal to left statue, and these are names that I gave them in tiled. So if you open tiled, when you click on the item over here on the left, you can edit the name and the class, and these are variables that you can access from with PyTMX. So the object.name we're getting, the object.class we could get, the width and the height, the X and the Y, we're getting all of these from the information that is put into your map in tiled before you save it. So if it's the left statue, we're going to make a generic object. Actually, I want these to be interaction objects. No, I think generic is fine because they have a hitbox. So we'll check for the collisions when we need to. So we'll leave it as generic for now. And the position is object.x times 3, object.y times 3, pygame.transform.scale, object.image, and I made these 200 by 200 for my statues and my fountain. Got an extra close parentheses there. That looks better. There we go. And the groups are going to be self.allSprites and self.interactionSprites. And then it's going to go on Farm Sim Layers main, so we don't need to put that in there because that's the default. So we'll copy that and do the same thing for the right statue. That's also 200 by 200. And then the fountain is 200 by 200. So I didn't make it an interaction because interaction doesn't have an image, but I did add it to interaction sprites. I wonder how that's going to work. Because for the next two, I added them to collision sprites. So we'll have to see, and we may need to change that in the future. So let's add 2 more. And one is shipping bin, and the other is mailbox. These are both 48 by 48. And instead of putting them in interaction sprites, I put them in collision sprites. And I think that's what I'm going to need for the others. I'm going to go ahead and change that now. I spelled interaction wrong anyway. That means I probably misspelled it. In all of it. Let's go back and check. 48 by 48. These will be collision sprites, interaction sprites. So those are spelled right. Let's make sure I spelled it right up at the top. I did not. There we go. Okay, so we call self.setup, which should make our map. And then we should have self.allsprites.draw, allsprites.update. I think that's all we need. Let's see if it works. Nope, what did we do wrong? I didn't do a layer for water. Let's look in config.py. I did not do a layer for water. What layer did I put it in my old code? In sprites. So it's just on the ground level. So let's go ahead and go back to sprites and change that from water to ground. Okay, let's try that again. Oh, I thought that was going to come up in sprites where we do our frame index for the water. This needs to be an int because multiplying it by delta time is going to make it a float. So we've got our map showing up, but our player is not positioned where they need to be. Or maybe they are, and we just can't tell because the map is zoomed in. So let's go ahead and create the camera while we're at it and see if that helps anything. So in sprites, I'm going to make a new file called camera group.py. This comes from clear code as well, from his camera tutorial and from his Stardew Valley inspired game tutorial. I watched both and kind of combined the two to get what I needed to get the camera that would not go off to where there was a black screen. It would just stay within the map. So we'll import pygame and create a class called camera group. And this inherits from pygame.sprite.group. Init will just take self. Then we'll do super.init, which doesn't take anything. Self.display surface is going to be equal to pygame.display.getSurface. Self.offset is going to be equal to pygame.math.vector2. Self.offset x max is equal to 1125. Self.offset x min is equal to 0. Self.offset y max is equal to 1680, and self.offset y min is equal to 0. Then we need let's see, a left, a top, a width, and a height. I believe is what these values stand for. L is equal to 200, T is equal to 100, width is equal to self.displaySurface.get size 0 will be the width minus 400, and height will be equal to self.displaySurface.get size 1, which is the height, minus 200. Self.camera rect is equal to pygame.rect length or left, top, width, height. All right, now we need a custom draw function. My O key is sticking. That's going to take self and a player. Self.offset x, offset.x is equal to player.rect.center x minus the screen. We'll do config.screen width divided by 2. Self.offset.y is equal to player.rect.centerY minus config.screen height divided by 2. Let's import config. And then to keep the camera from going off of the outside of the map, so this was a lot of guess and checking. I basically increased my player's speed and ran to the top of the map and to the bottom of the map and to the right and to the left and replaced these values until I had it right, until running to the end of the map stopped the camera at the end of the map. So now we're going to use those values, and I'm just going to copy this in. If self.offset.x is greater than self.offset.x max, then the offset.x equals self.offset.x max. If it's less than the x min, we'll set it equal to the x min. Same for the y. If self.offset.y is greater than the offset y max, we'll set it equal to the offset y max. And offset y min, oh, it's just because I was clicked on it. If self.offset.y is less than the y min, then we'll set it equal to it. And then, let's see. We'll do for layer in config.farmlayers.values, so just the values, not the keys. For sprite in sorted self.sprites, and the key is equal to lambda sprite is a colon sprite dot rect dot I cannot type today. Center Y. If sprite.z equals layer, offset rect is equal to sprite dot rect dot copy, offset rect dot center is minus equals self dot offset, and then self dot display surface dot blit sprite dot image, and then offset rect. So that should move everything with the player. When we move the player, it moves the position of the sprites. So now, back in farm, instead of calling self.game or self.allsprites.update, or self.allsprites.draw rather, well, first we're going to change all sprites from pygame.sprite.group to a camera group, which, but it needs to take player. Doesn't it? No, custom draw takes player. Okay. So self.allsprites is equal to a camera group. So we'll import that. And then down here, we'll do self.allsprites.customDraw. And that's going to take self.player. And then we'll do self.allsprites.update with delta time. What does that do? Player object has no attribute z, so we need to add a z to the player. So that's just going to be main. That right here, self.z is equal to config.farm players main. We'll import config. All right, let's try that. There we go. And if we go up, our map stops. If we go to the right, that's the left. Oh, we have a problem. Oh, we haven't added collisions yet. That's okay. And you see we're behind the trees now. We should be able to walk behind the house. We're able to walk through the trees because we haven't added collisions. But we're walking behind the house. Once collisions are added, we won't be able to walk through these squares here. Same for the water. And if we go here, the map stops right at the edge of the screen, even though the player keeps moving to the right. The map stops. And let's check the bottom. We got a ways to walk. And the map stops right at the bottom. All right, that all looks good. We've got our map on the screen. We've got our trees. We don't have our trunks because I didn't create those yet because I'm going to do the stumps in a different way than I did the trees because the trees are going to grow back. So I don't want to create the stumps as trees because then they would just grow back as well. We can walk up the hill. That all looks good. In my next tutorial, I will work on adding the collisions. and I'm not sure where we'll go from there. Maybe I'll work on getting the stumps going as well, or updating the tree class. There's a lot of things I could do, but definitely the collisions I want to get done in the next tutorial, or the next video rather. So that's all for today. Thanks so much for watching, and if you enjoyed this video, please give it a like and consider subscribing to keep updated with my game progress. Thanks so much, and I'll see you next time.